Okay, so we're going to do a couple of examples. We're going to work on page 1 and 2 of the examples for this packet, section 12.1 to 12.2. Remember, you also have examples in your book as you're working homework. So one of the things I like to do before I get started when I'm working with kinematics is just think about scenarios. So if I have constant velocity, so if this is my velocity and it's constant, here's my time, then I know that my acceleration, I'm not accelerating, and I know that I have a constant position change over time. So this is if my cruise control is on. Okay, so I'm going 55 miles per hour and I'm traveling down the road. So normally I would do acceleration, velocity, position, but I just want you to get started. So what if I have a uniform acceleration? So uniform acceleration is like constant. So this is my acceleration with time. And this is a 0-degree curve. So I know that my velocity is going to be 1 degree. And I know my position is going to be 2 degree. Okay. If I have linear acceleration, so here's my acceleration. This is at 1 degree. My velocity is going to be 2 degrees. And my position is 3 degrees. And so that way it just helps me know I am integrating if I go this way. And I'm taking a derivative if I'm going that way, okay? So instantaneous. Given our velocity, what is our velocity when t equals 2? So our velocity equals 4 times 2 seconds plus 5 equals 8 plus 5 equals 13 meters per second. So that would be my velocity instantaneous. Oh, I guess you can't see that if that's on there. I don't know how to get rid of that. So let's go on to the next page. And here we're going to start with when our time is 0, we have a particle which is 1 meter to the left of O. So if this is O, it's 1 meter to the left. In 4 seconds, it travels to B, which is 8 meters to the right. In another 6 seconds, it travels to C, which is also to the right. So the first thing I'm going to do here is I'm going to draw kind of a little number line. I know that here is 0.0, and I'm going to come over here to -1, and that's my starting point. In 4 seconds, it travels to 8, which is also to the left. So here is 8. And my time in that is 4 seconds. And then I'm going to travel to C, which is at 7 meters. And this was 6 seconds. So it says determine the average velocity and the average speed. So remember that our velocity average equals delta S over delta T. And this is displacement. It is final minus initial. So if I'm looking at this, I have final is 7 meters. Initial is -1. So I have 7 minus -1 meters over 10 seconds. And I get 8 meters per 10 seconds. So I get 0.8 meters per second for my average velocity. And remember, our average speed is total distance traveled divided by delta t. So my total distance this time is -1 to 8. So if I look at that, I can just go on here and mark if I want to. I don't have to do real math. And I can say, well, that's a difference of 7. This difference right here is 8. This difference right here is 7. So my total distance traveled is 14 plus 8 over 10, which is 22 over 10, which is 2.2 meters per second, and that's for my speed. Okay. If S equals 2t cubed, determine velocity. So let's start looking at our equations. These equations are a function of time. This is a function of position. S is a function of position. Determine velocity. So I'm going to be dealing with this. V equals ds dt. And I'm given S is in terms of t, so I'm going to keep the dt right there. So velocity equals d, 2t cubed dt equals 6t squared, My velocity at 2 seconds is 6(2) squared is 24 meters per second. Okay? So let's go down to the next problem, and it's why it's super important to understand what we're doing. Here we have our velocity, and this time we are given it is a function of position. So when we're looking at variable, okay, function of position, I'm going to start with v dv equals a ds. Okay, and I'm given an equation for velocity of 2s, and I'm trying to find acceleration, my function of s, so I need to divide over by s so that my acceleration is v dv ds. And now I have an equation for a velocity of 2s, and I can take the derivative of 2s with respect to s, and I get 2s times 2 equals 4s, so my acceleration is 4 times 5 equals 20 meters per second squared. Okay? Here I'm given my acceleration is in terms of position. So again, if I'm looking at position, it's this set of equations. So I have v dv equals ads. This time, my acceleration has the function of s, so I'm going to leave the ds over here. So I have 3s to the 1/2 ds, and determine velocity when, so okay, I apologize. I know the video jumped because I made a mistake, so I had to kind of do it. So we're doing a as a function of s, and we are wanting to find the velocity when s equals 13 meters, given that our velocity is 2 meters when our position is at 3 meters. So we have boundary conditions here that says when velocity is 2, position is 3. So as we're integrating, we are not always going to go from 0 to velocity and 0 to position. We have to pay attention to the boundary conditions given. So I am going to be integrating from 2 to velocity, v dv equals from 3 to position, 3s to the 1/2 ds. So the boundary conditions is what we are integrating with respect to. So now I've got v squared over 2 from 2 to v equals, remember with the 1/2, I'm going to add 1 to it, so it's going to be s to the 3/2 divided by the reciprocal, which will take care of that 3. So now we have 2s to the 3/2, 3s. So when I start plugging these things in, I have v squared over 2 minus 4 over 2 equals 2s to the 3/2 minus 2 times 3 to the 3/2. Okay, so when you're doing, especially when you're doing with the position, you have to keep in mind it's not just a straightforward integration. If you have boundary conditions, you're going to have to remember how to set this up. So when I get this set up, I'm going to end up with an equation, v squared equals 4 times 15 to the 3/2. So there's a lot of simplification taking place, minus 16.78. So there's some math work that took place here. And now I can calculate, that's with the 15, the time that I'm looking for. And when I calculate this out, my velocity is 14.68 meters per second. So I started with acceleration as a function of position. I integrated, and I'm ending up with a velocity when position is 15 meters.